Hello and welcome back to a new lesson. Today I will talk about capacitors, how to select a capacitor to your design, and what are the main differences between them. Capacitor is a simple passive component that can store energy inside it, like a battery, but can store way less energy compared to batteries. If we go to Eagle and search for capacitors in RCL library, we will see different types and packages. So, understanding them would let you choose the correct one for your design. So, how to choose a capacitor and what makes them different? These differences are polarized or non-polarized, capacitor material type, voltage rating, tolerance, and finally your application requirements. First, let's talk about polarized capacitor. Polarized capacitor is one that must be run with a voltage across it in a certain polarity. That means all polarized capacitors have a positive and negative side. Reverse bias can damage or destroy them. Electrolytic and tantalum capacitors are always polarized and come with THT and SMD package for both of them. Polarized capacitors are used in DC coupling for audio application and DC supply circuit as a ripple filter, and many more. On the other side, non-polarized capacitors do not have polarity, so you don't need to pay attention to how you connect it, since any reverse bias cannot damage or destroy this type of capacitors. And this type of capacitors come in SMD or THT package with different types like ceramic and film capacitors. Now, based on the material, we can sort them to electrolytic capacitor, which is consisted from aluminum oxide and can be available with high capacity in farad. Ceramic capacitor is the most popular type and used in a vast quantities with SMD and THT package. Film capacitor is a non-polarized and mainly you can find it in a through-hole package and rarely you can find it in SMD form. And the last but not least is tantalum capacitors, which is similar to electrolytic capacitor, and thanks to its smaller size, you could save some space in your design by using it. Voltage rating. Pay attention to this aspect carefully. All capacitors come with a maximum voltage that the capacitor can handle. Now, if the voltage applied on the capacitor was higher, then the capacitor will explode. For tantalum and electrolytic, you will see the voltage rating written on them. But some capacitor doesn't have any indication about that, so it's very important to organize your capacitors and sort them based on the voltage rating. Ceramic capacitors in general can handle more the voltage spikes, so if you applied more than the maximum voltage rating on them, they could handle it very well, unlike the tantalum capacitors, which will burst in fire if the voltage applied exceeds its maximum voltage. Tolerance. Capacitors would come with tolerance from 1% up to 100% in some cases, like the electrolytic capacitors. Film capacitor has a tolerance up to 10%, while electrolytic capacitor could have a tolerance up to 100% in some cases. So, choosing film capacitor is better with any application that requires a precise capacitance value, like RC filters and some amplifier circuits. As a quick example, if 10 microfarad capacitor has a 20% tolerance, the actual value will be anything between 8 to 12 microfarad. And finally, your application requirements. So, based on your project, what is the maximum PCB size you have? What's the application? The voltage that your circuit must withstand. Secondly, the assembly. THT package is easier to solder if you have the basic soldering iron, but for mass production, it's better and less expensive to use SMD components. Third, ceramic capacitors are the standard for most applications. Most of film capacitors come with THT package, and rarely you could find them in SMD package, especially in high values. Pay attention to your circuit voltages. Check the component's dimension and ensure to select a footprint that will fit your component. And it's a good thing to check another designs as a reference so you can check the choices and avoid any mistakes. Also, check the datasheet related to the component you are using. Most of the time, the datasheet will give you some instruction about what type of capacitor you should use and what you shouldn't. That was a quick guideline to a capacitor's types and differences between them. See you next time with our first project.